Previously, we learned that a charged particle moving in a magnetic field may experience a magnetic force. In this video, we're going to focus on a wire that's in a magnetic field, specifically a wire that has a current moving through it. Since current is comprised of moving charges, if a current carrying wire is in a magnetic field, it also may experience a magnetic force. Now we know that those charges experience a magnetic force according to the equation QV cross B. So let's say that we have a length of wire L that's actually in the magnetic field. The whole wire might be longer than that length L, but we're only going to focus on the portion that's in the magnetic field. So thinking about the velocity vector that we have here, we know that velocity can be expressed as displacement divided by time, especially if we're looking at the average velocity. And so if I plug that expression into my magnetic force equation, I get that Q times L over delta T cross B gives me that magnetic force. And notice that I've added the vector symbol to the L there, representing the same direction as the velocity. Well, we also know that current is defined as being the rate at which charge flows in a wire, or dq dt. And if we have a constant current, we can express that as delta Q over delta T. So looking at my equation for magnetic force, you'll notice that I have a Q over delta T in my equation. So I can replace that with an I to come up with an expression for the magnetic force felt by a current carrying wire in a magnetic field. In this expression, the magnetic force can be found by doing IL cross B. In this case, the direction of L would be the same as the direction of the velocity of a positively charged particle, which we know as being the same direction as the current. The only reason that L is our vector rather than I is because that L comes in from that velocity vector. So in the end, that whole wire is going to experience a force, and depending on the net force on that wire may move. Just kind of illustrating that point one more time, if I take a look at this image you see here, if the current is 0, like on my diagram on the left, that wire will experience no force whatsoever. If the current is moving upward, and this example has a magnetic field pointed outward, then the force would point to the right, and I can determine that using the right-hand rule. If the direction of the current changes and is moving downward instead, then that force would point to the left. And so my wire would bend like you see in these scenarios here.